Well. Right now, we have Danila Kornev connecting to us, Deputy Chief in charge of hands-on solutions at DeepPavlov. He'll be telling about the latest advancements at the library for conversational AI with open code for the achievements of goals and scenarios. So welcome Denis Kuznetsov, the researcher from DeepPavlov. Hello, my name is Denis Kuznetsov. Let me tell you about the framework that we developed to quickly write dialogue bots. Today, we will consider roll-off not only for chatbots, with the use of machine learning model. Well, today, we'll look through the following points. Why it matters, why it's important today to write chatbots, how we began to develop our framework. We'll discuss major concepts of DialogFlow Framework, and we'll see how you can start your very own project using DialogFlow Framework, DFF, and we'll discuss the status of the framework. What's the state of the development for the time being? Naturally, DFF executes a minimal set of tasks, so if you want to extend its functionality, you would need to use the add-ons system, and we shall be speaking about that as well. We'll also discuss the SDK. That's a specialized project that contains ready-made cases for application based on the DFF. It also shows the use of ML models, specifically for the dialogues. Well, the importance of writing dialogue bots today is especially important because large corporations invest a lot into creating their own dialogue assistants. You know, Alexa, Cortana, Siri, Google Assistant, Lisa from Yandex, etc. Chit-chat bots are purchased by call centers to optimize their pipelines. Also, messengers, websites use chatbots in their services. We were pushed to develop this framework by the team who won the first prize at Alexa Challenge in 2020. The team's name is Imora. They have been using as a core for their solution STDM, the platform for roll-off skills, in which they were using algorithms for machine learning as annotation and many other things. So when we participate in Alexa Prize 4, we took their code as a basis, and we have written our very own wrapping to extend functionality. By the end of development of our solution, we added a number of functions with simplified DSL. DSL is a language that allows us to write dialogues, scenarios for dialogues. By the end of Alexa Prize 4, we decided to fully rewrite the framework based on the feedback during the competition. So that helped us to remove STDM and very significantly improve and simplify DSL framework. By the end of summer, we have trialed and tested the beta version at the Samsung Summer School, and yesterday we were presenting at EMNLP workshop, and we have shown the recommendation system that allows very quickly write dialogue scenarios, and I truly recommend, and it can truly recommend which not to select. And it's all presented in the UI that is imported into VS Code as an extension. When we were developing DFF, we took into account the philosophy of sort of Unix way. We were trying to make DFF minimalist, modular. I mean, it solves one particular given task very well. We have split the entire solution into independent modules so that it would be easier to develop them. Since DFF naturally is minimalistic, and it doesn't have all of the possible functions and capabilities. We have considered the system of add-ons, which you can use to extend the basic functionality of the framework. Also, we have been particularly developing the expressiveness of DSL that's used to write scenarios so that you could write your dialog scenarios with a minimal number of lines in the code quickly. The fundamental principles. It's based on 3 scenarios. On this image, you can see the context that comes to the user. We add the request to the previous one and annotators, which are normally ML models that mark up the last phrase of the user and the context. It goes to the actor, the context goes into the actor, actor executes operation based on what's written in a scenario in our DSL, and that returns context with the asterisks. That context already has the answer of our actor, and then we have the actor response, which can be conveyed to the user. So what do we begin with? It's very easy to install pip install DFF and you get the latest version. And the code base is available there at the link below. So, if you want to start writing code, you can begin with importing first keywords from the keywords module, transitions and response as the 2 keywords that describe transitions within the scenario. And responses describe answers that we will be returning to the user. Similarly, we were going through abstractions, contexts, and actors that are also imported from the core module of the DFF. And for the convenience, we import conditions that will allow us to define the conditions of the transition. So here are the options of the scenario. In the beginning, let us imagine the scenario is a graph. And in every graph, there are nodes. In every node, there's a certain answer of the user. It can be with a separate line or a function that is being called from the external IP, or it calls the models and generates the answer to the user. The graph can be big, broad, and often when we write a scenario, we split scenario into several parts. They can be united according to principles. For example, a subject, we have 2 scopes here, 2 subjects in the terminologies of BFF. One about news, another about small talk, for example. Let's move to the code. To the right, you see the code. And it shows first our flow. It's the key that reflects the title of the topic. And you see there's the list of nodes that are within the graph. And in every node, there's the answer that the user receives while getting into this node thanks to a keyword response. And we have here a value, which is either the answer or the function that returns the answer. There's also keyword transition that, as I have said, is in charge of transition between the nodes. And in this case, transition contains keys, the address to the transition, if there is condition match, exact match, if it's true, if one of the conditions is not true, the next condition is being checked. If it's true, then there is the transition to a different node. We have exact match, we have true, we have regexp and other functions available out of the box. You can take a look at all of them in the history of our solution. Now, what we had previously on the graph, let us try and replicate that in the code. First and foremost, we have written the script of our dialog in advance. Plot We're sending the plot into the entity actor, and this is the start of our dialogue. We create the context and put the request of the user in that context. The author get context and get the context with asterisks, and context contains the latest answer of the user. We can here take a look at the example of how the interaction with the bot is happening. Hello, for example, we are in the start node, node high, and then the transition that we have, they check the match. So if the first match is not true, we have hello, but we're expecting hi, and there's a second transition, which is always true, and we transition from this node into the node with the flow address, and the node is called OK, and that node returns us OK. So the bot says OK, and therefore this is the conversation. So what's the current status? We are already accessible at PyPI via the install. At the moment we support Python 3.6 plus. We have 100% coverage. In the repository you can take a look at the examples for fully functional DFF. DFF is documented actively at the moment, and we are moving into the beta. By the end of the documentation, it will be wrapped up. Now, add-ons. As I've said, DFF executes one function, but really, really well. Since there are not many functions, we want to expand our capabilities. For that, we're using the system of add-ons. It allows us to quickly and easily implement our solution. Now we'll take a look at the add-on that we have written. All of the add-ons that we're trying to publish them in the open source and make them accessible. This add-on represents gives access to stats, so you can use it for having done pip install DFF. You can install the additional stats node and check dependencies so that this stats would be reflected in the dashboard. Here's the example of the code. For the time being, this add-on helps you to get stats via dashboard, via REST API, and collect stats. So you would give your solution to users, they talk to bots, and then you collect stats. You check the behavior of the users and check the stats. Here's the example of our very own data that show us timing, the latency in every node, so you can evaluate whether your input is fast or slow. Also, you can see the entire graph through which the user travels, and there are counters that identify the frequencies, showing how often the user gets to a particular node, and in between nodes there are transitions, or the identifiers of probability of moving from one node to the other. Here's a trace via nodes for a particular user. So down the x-axis we have number of turns, and on y-axis we have our nodes. And we observe here how user travels from starting node to further nodes. Twice the user repeats the same node, gets to the same node. Ask about breed. Also, we have node counters for every particular node, matched by color, marked by color. Also, the dashboard shows the frequency of transitions and time latencies in seconds for every node, meaning how long the bot answers in every particular node. So let's look at the major principles of add-ons for DFF. Easy to install, easy to create your own add-ons. documented. They are documented, plus there are examples. We're publishing all of our add-ons into open source, so we're trying to make kind of a multi-shard open source. We add documentations and examples. Also, we have plans for the development of future add-ons to collect data for ML models. And also, we can offer broadened testing of our scenarios thanks to specifically prepared dialogues. Also, we have SDK for DFF. It's been successfully developed. The SDK is made so that you could see how you can be using complex models with a lot of ML models together with the DialogFlow Framework. It has frequency of activities. It has now a big number of ML models, which you can take a look at and use. We're going to update documentation, add examples, and those best practices that we could develop while we were participating in Alexa Prize, we're going to add those to our capabilities. And also, we're actively trying to migrate our Dream platform to, we're migrating DFF to the new versions. So, we have migrated about 25% for bare skill, and 10% are updated to the new DFF. The new skills will only be implemented on DFF. On the right, you see the example of how in the VS Code you can observe visualization of our graph. And our further steps are documentation, factoring. Further steps is what we're planning to add and develop. Controllable generation, learning policy, graph generation, emotion generation. We're planning to use the policies that could be taught. We're going to use graph generation and create model that will be measuring graphs and actively publish that. There are links available here. Thank you very much for your attention.